Welcome to you all to the lecture series of Digital Electronics KV 039/049. We are in lecture number 26. Myself Dr. Kishanu Kundu, Assistant Professor, Department of Electronics and Communication Engineering, GL Bajaj Institute of Technology and Management. So, we are discussing about asynchronous sequential circuit, and today we will going to design that type of circuits. So, let us start. First of all, we will check it out what are the design rules. So, you can check it from here that with the process starts with designing of a primitive flow table, then we will merge the rows of primitive flow table, and then we will assign the binary state variables to each row of the reduced flow table to obtain the transition table, and in the fourth step we will assign the output values to the dash associated with the unstable states to obtain the output maps, and finally the simplify the Boolean functions of the excitation and output variables and draw the logic diagram. We will take an example and we will check it out all the steps one by one. So, start. Here we have taken a design example. What is written? Design a gated latch circuit with two inputs G and D. See, these are two inputs D and G, one output Q, one output Q. Two conditions: the gated latch is a memory element that accepts the value of D when G is equal to 1. So, here D is equal to 1, okay, where G is equal to 1. So, when G is equal to 1, D will be of two combination either 0 or 1, we have written like this. So, the format is like that D, G and then Q. So, first we will put the value of D as 0 and then D of value is 1, right. G will be 1 for both the cases. So, we have written 1 in both the cases, right. And what about the output Q? It is written as that it will retain the value, right, it will accept memory element same as input. What is memory? Output will be same as input, that is the memory. So, out Q will be same of D. So, here value of D is equal to 0, here value of D is equal to 0. So, output will be also 0, here value of D is 1. So, output will be also 1. So, we have denoted this as small a and this is small b. Our up to this condition is over, right. Now, once G is 0, when G is 0, then we will again start from this two condition A and B, right, and there will be also two condition of D, one will be D will be 0 and 1, again D will be 0 and 1, every time D will be having two values 0 and 1, and in this case all the cases G will be 0. So, you have written 0, 0, 0 and 0, all G values are 0, okay. And one more thing, D does not change the value of output of Q. Previously Q was same as of D, but here Q is not changing. So, let us check it out. Here value of Q is 0. So, 0 will be retained in both the cases, right. Here value of Q is 1. So, 1 will be retained in both the cases, 1 will be retained in both the cases, right. These are the same, this is nothing but this is right, okay, both are same. So, we have got total how many states A, B, now this is C, this is D, this is E and total F, total we are having A, B, C, D, E, F, these states we are got, okay. This will be used for making the first table. See, we have written these states and the inputs values, this is the output values, already I have shown you A is nothing but 0 1 oblique 0. So, we have written 0 1 and 0 D, G and Q, it is clear to all of you, okay. Then what is B? B was 1 1 1, D value 1, G value 1 and output is 1. So, again we have written here 1 1 1. What is C? C is here 0 0 0. So, we have written here 0 0 0, okay, clear. So, we have up to this we have completed. How it is coming, it is clear to you, okay. Now, here it is written some comments. See how A is coming, A is coming like this, when G is equal to 1 and Q will be same as D. So, that was the comment for A, we have written here. same comment was for B also, because when G is equal to 1 and Q is same as D, we are getting the value of B. So, we are having the same comment here. Now, for C, when C is coming, C can be coming in either directly after A, C can come. Is it visible to you? Okay. Either C will come from A or it will come after D, right. So, we can write that C can come after A or D, C states can come after A or D. Similarly, D will be coming after C only, right. C is coming after, sorry, D is coming after C only. Similarly, what about E? E can come after B or F, E can come after oblique B or F, and what about F? F can come after E only. So, these are the comments already you have written here, you can check it out. Okay. This is the table with all the states. Now, we will be forming the primitive flow table from the steps. What are the steps for that? First step is, first we will fill one square in each row belonging to the stable state in the row. What about the stable states? See, stable state means suppose A value was 0 1 oblique 0, this is A, this is B 1 1 oblique 1, this is C 0 0 0. Already I have taken this, already I have written here, again I am writing in this slide, right. And what are the values? This is the D and G and this is Q, okay. This is the format, right. So, now this box's format is state value and output, and DG will be 2 variable though 4 combination. So, 0 0, 0 1, 1 1 and 1 0, right. So, we will write like that. Now, the first step is rule is we fill one square in each row belonging to the stable state in that row, stable state. So, value of A is 0 1 0, here this is 0 1. So, we have written A and output is 0. So, we have written 0 and we have circled it because it is a stable state. So, first of all we will fill the stable state. Similarly, value of B is 1 1. So, 1 1 this column, here it is written B and the output is 1. So, we have written 1 and we have made it circle, means it is a stable state. Similarly, C is 0 0 0. So, this column. So, here we have written C and we have made it circle to make it a stable state. Stable means C C, right, present state, next state same, this is stable state. So, an output is 0. Similarly, for D this is the case because D value is, D is nothing but 1 1 0 oblique 0, E is nothing but 1 0 oblique 1 and F is nothing but 0 0 oblique 1. So, like that you can check it out, okay. Clear all of you? Now, so we have written for D, E and F, okay. We have completed the full table. Now, next rule, next recalling that both inputs are not allowed to change at the same time, means both inputs cannot be changed, either D can change or G can change, but D, G both cannot change at the same time, means 0 0 cannot be changed to 1 1, 1 0 1 cannot be 1 0, right, but this is possible, 0 0 to 0 1 is possible, 0 0 1 to 1 1 is possible, 1 0 to 1 1 is possible, one variable change is possible, one input variable change is possible, but two input variable cannot be changed at the same time. So, what we will do in that case? We will enter a dash mark in that case, we will put a dash mark in that case. So, just check it out. See, A value is 0 1 0, 0 1 0. So, 0 1 and 1 0, this is not possible, 0 1 and 1 0 is not possible. So, do not care, we will put a dash dash, okay. Next, B is 1 1 1. So, 1 1 to 1 0 0, this is also not possible. So, we have put a dash dash, clear. For C, C is 0 0. So, 0 0 to 0 0 to 1 1, this is not possible. So, this column and here we have put a dash dash, got it. Now, for D, D is 1 0 0. So, D 1 0 2 0 1, this is not possible. So, 0 1 means this column 0 1. So, here we have put a dash dash, got it, which states is not possible, that is entered as dash dash, right. Similarly, for E also this will be, this column will be 0 1 will be dash dash, and for F it will be 1 1, this column will be dash dash. Up to this I think it is clear to all of you. Next we find values for 2 or more squares in each row. The comments listed in the previous table may help in deriving the necessary information. Now, the comments whatever we have written here, this will be helping us for designing the further. So, here you can check it, A is 0 1 0 and this is 0 0. So, 0 1 to 0 0, yes, it can be possible, only one variable change. And what is the value of 0? C, value is C. So, we will write here C, but here A was output is 0 and for C is output is also 0. So, we will be writing as 0, output will be same for both the case, right. Next 1 1. So, 0 1 to 1 1, right, 1 1 is nothing but B, 1 is nothing but B. So, we will write it as B, but here for A output was 0, for B output was 1. So, do not care, conflict, output conflict. So, it will be put as dash, got it. Similarly, here B is 1 1 and this is 0 1. So, 0 1 means A. So, now it is also conflict, output conflict, state change will consider, but output if conflict, then we will put a dash. Okay, clear? The format, this is the format, state and output, state and output. Okay. So, this will be A dash. Now, similarly, this is E dash. Now, for C, for 0 1, C 0 1, yes, 0 1 is A, and both the case will be having dash, right. Now, we will check 1 0, 1 0 is D, it is D dash, D dash. Now, for D this is C dash, F dash, here it is B dash, B dash, and here it is A dash, dash dash and E dash. See, again I am taking one example, this is F, F means 0 0 1 and A is 0 1 0, right. So, change is A, state change is A and output is 1 to 0, then that is why dash, got it, clear all of you. So, like that we have to format this primitive table. Now, next is we will reduce this. So, for reduction and this reduction will be called as implication table. So, how will we do this? We are having this test A, B, C, D, E, F. So, here A, B, C, D, E, but F will remove F. Similarly, here B, C, D, E, F, A will be removed. Okay. So, first and last like that we have to remove, this is the rule for implication table. So, for implication table just same this table will be converted into implication table, we will check it out. See here, first of all we have to compare A and B, these two states we have to compare. So, let us check it out, here A value we can remove all the other thing, it will be easy for you to understand, we will remove this. So, we will just focus in A and B, these two, we will just focus in both the things. See A C comma 0 dash dash. So, do not care, no problem, we will not consider. Then A, next this is also A, output is do not care. So, okay, B, B, outputs is one is dash, one is well, do not care, one is 1. So, no problem, and this is state E dash. So, do not care. So, see these are same. So, we can write these states are same A and B, right. Similarly, for we will compare A with C, A with C. See, this is A and C will compare C 0 C 0, okay, A 0 A dash, right, because output is do not care. So, no problem, states are same na, A and A, okay. Next B dash and dash dash. So, state is also do not care, output is do not care, no problem, then dash dash and D dash, okay, means both are same. So, we can like that we can write this is also same. Similarly, in this way whatever states will be same, I will just take it down this will be same formula whatever I have told you. So, this much will be same states, okay. You have to check like that, once I have done it for you, you can check by your own, okay. It is very easy, you can do it by your own. So, now we will take a condition where the states are not same. So, let us check this one, we will check the this case, this E A and E, we will check both them. Let us do it A and E. So, A is C 0 and E is F dash, conflict, this is C comma 0, this is F comma dash, output is do not care, but state no, not same. So, is a conflict. So, we will put right that C comma F, got it. Now, again we will check it out if any further difference is there. See A 0, this is dash dash, okay, do not care, B dash same, and dash dash E comma 1. So, it is also do not care. So, no problem. So, this conflict is there C and F, right. So, this is done. Now, again we will check now we have to write the one more thing, here we have to write the output also we have to check, but once we will check the output, here we will took a comment that this C can be done after A or D, after A or D. So, here we will check this one, this A or D will compare, then we will check it out, okay. Similarly, F is also like C and F, C and F, right. Now, for this one C and E, check it out, C and E, what is C? C is C and E, C F conflict A dash, okay, do not care, dash dash B dash do not care, D dash E 1 again conflict. So, here 4 combinations C, F, D and E. So, all will write here C, F, D and E and output cross, okay. So, like that we will be having this cross, and if this C and E is cross, so here also we will be writing it as cross, okay. That is why I have not written here only. Now, these two things you have to check like that, this is D cross, this is also D cross, one I have told you, you can do the rest of the things. Now, for this one, this is also will be cross, then this one is D C, D E, C F and cross, okay. Actually, our main focus will be same, this one tick one where both the states are same, because we have to make the compatible pairs. See, these are the compatible pairs, whenever we have put the tick mark, that are the compatible pairs. See, here it is A B, one compatible A C, then A D, these are the compatible pairs, okay. Other compatible pairs you can do it by your own. What are the compatible pairs? B E, B F, C D and this one last one is E F. So, these are the compatible pairs. Whenever the states are same, exactly same, right, that then they are called the compatible pairs. So, here it is two states are compatible in every column of the corresponding rows in the float table, they are identical or compatible states if there is no conflict in the output values. So, they are called compatible pairs, and these are the pairs which are the compatible, right. So, now from this compatible pairs we will find out maximal compatibles, maximum compatibles. Okay. How to find the maximum compatibles? So, here we will put that this is A, B, C, D, E and F. What are the pairs? Our pairs were A B, our pairs were A B, A C, A D, A B, A C, A D. Okay. Rest of the pairs B E, B F, B E, B F, C D, E F, B E, B F, B E, B F, C D and E F, C D and E F. These are the pairs. So, we will just draw lines. This straight line here, this line represents a compatible pair. Okay. The compatible pair will be designated by a single line, straight line. So, first is A B, this is A B, then A C, A C, then A D, this is A D. Now, B E, B E, B F, B F, C D, C D and E F. Got it? Every straight line are as a compatible state, okay, straight line. So, now we can check it the one there is a triangle is making. Okay. This triangle, see here one triangle is this one ACD, one triangle is ACD and second triangle is BFE, second triangle is BEF or BFE, whatever BEF, second triangle is BEF and one is left AB. So, these are the maximum compatibilities we are having. Okay. This is the maximum compatibilities we are having. So, just check the theory here. The above master diagram is obtained from the list of compatible pairs already you have derived. In the implemented, a line represents a compatible pair, I have already told. A triangle constitutes a compatible with 3 states. Here see 3 states A, B, A, C, D, one triangle, A, C, D, one triangle. Okay. So, the maximum compatible pairs are A, B, A, C, D and B, F. Is it clear to all of you? In this case, where a state is not compatible to any other state, an isolated dot represent this state. If there is no, here it is nothing is there, but if it is no stable state is there, compatible state is there, we have to present it as a dot mark. Okay. You have to remember this one. Now, we have to reduce the primitive flow table. Already primitive flow table have been formed, now we have to reduce this. So, what is the steps? Can be reduced with a smaller number of rows in stable state are placed in the same row of the flow table. Thus, merging rules are as follows: 2 or more rows in the primitive flow table can be merged into a one, or if there is non-fitting states, the output in each of the columns. Whenever one state symbol and do not care entries are encountered in the same column, the state is listed in the merger row. If the state is circled in one of the rows, it is also circled in the merged row. The output state is included with each stable state in the merged row. So, we will apply these things. So, here we are having these A B, A C D and B E F. Okay. So, we just write down A C D and B E F. How we have written here? This is nothing but this table. This table is now reduced. We are having taken this full value of A. Those full value of C comma 0 A, you can check it out, C comma 0, this is same values, A comma 0, actually here it is not 0, it is dash, okay, it is not 0, one second, it is dash, So, same values we have just put there. So, we have made this table from the previous table. So, this is one is for ACD and one is for BEF, right. Here these are the DG values 0 0 0 and 10. So, now we have just circled the stable states in each case, okay. Same thing, got it. Now, what is the next step? Each part shows the 3 stable state that can be merged because there is no conflicting entities in the 4 columns. Okay. Now, we can see here all are same, you can see that C dash, C comma dash, C comma 0, C comma dash. So, all columns are same, right, like this A comma 0, A comma dash, comma dash, no change, B comma dash. So, we can merge it, we can simplify it, only one we can write. So, we have merged it, one for ACD and one for BEF, right, because all are same. So, the first column of can be merged into a stable state C of the output 0, the second the stable state with A or output 0, etc. So, same thing we have written, see here this one is written CD, this one has been taken, then we have taken this one, then we have taken B dash, then D comma 0, C B dash D comma 0, okay, because all rows are same. So, we have merged into one. ACD is single, ACD can be ported as A, right. Similarly, BEF can be ported as BEF can be ported as B. So, we have written like that, okay, clear. After this is the reduced table, 2 alternatives, got it. Now, we have the thing, now we have to make the transition table and logic diagram. So, we are in the 4th step here, see we have started with that transition table, right, this thing we have to take. So, now how to make the transition table, already this is easily understood by you, right. Now, the next one is, see this is the values, this is for DG and one is for this is the output, this is for state and this is for output, okay. So, we can check the output like this 0 0 dash 0, right, and this is 1 dash 1 1 1 dash 1 1. So, for output we will put it here, देखो, see this one 0 0 1 0, write that, see 0 0 1 0 and got it, okay. So, this is for, this one is for states and one is for output, okay. So, we will be having this one transition table algorithm. To obtain the circuit described by the reduced flow table, a binary value must be assigned to each state, we have done it, A and B we have assigned. This converts the flow table into transition table. Now, in assigning binary states, care must be taken to ensure that the circuit will be free of critical races. No critical races can occur in a 2 row flow table. Already races we have described in the previous lectures, if you have any doubt you can follow that. Assigning 0 to a state A and 1 to a state B in the reduced flow table, the following transition table is obtained, okay. We have assigned A to 0 and B to 1, okay. So, like that, see here we have A to 0 and B to 1, okay. This will be 1 1, wherever we have having B we will be putting as 1 and wherever we are having 0 A will be putting 0. So, it will be 0 0 1 0, this will be 1 0 1 1, 0 0 1 0 1 0 1 1, this thing 0 0 1 0 1 0 1 1, got it, clear. So, if we have, then we will be combining, this will be a combination and this will be a combination, okay. So, this is value will be y will be, this value will be dg plus g bar y, okay, got it. And for next, for output we will be having 0 0 0 0 and all ones. So, this is will be having y and this is dg. So, the output will be q will be y, So, we have got two equations, this is one equation and this is second equation. Okay. So, now this Boolean expression can be formulated into the final diagram. See here it is coming as d g and this is coming as g bar y. So, this is y is nothing but d g plus g bar y, okay, and this is q and y is equal to q, y is equal to q. Okay. So, this is the final diagram. So, we have completed the designing of a asynchronous sequential circuit. These are the main rules you have to follow. This primitive flow table is very important. For that we have to understand the question very clearly and then we have to formulate the primitive flow table, then we have to do the implication table and then we have to find out the compatible pairs, then maximum compatibles, and after finding the maximum compatible we can merge them into single one, that is like that A C D can be combined up to like A and A B F into B, okay, and later on we will assign value like that A will be 0, A will be assigned to 0 and B will be assigned to 1. Okay. So, like that we have made it and we have formulated the transition table and finally, we have got this logic diagram. This is the reference and thank you.